Hi, and welcome to Verisk's Emerging Issues. My name is Greg Scobletti, a researcher and writer with the Emerging Issues team. And today I'm going to be reading our article from September 14th titled, "The U.S. Wants More Chips and Less PFAS. Can it have both?" Let's get started. If the tech economy had a beating heart, it would be the semiconductor. Central to everything from cars and smartphones to medical devices and military equipment, the semiconductor industry reportedly sold 1 trillion units around the world in 2022. For all its importance, the semiconductor supply chain is extremely complex and dispersed. And, as the COVID pandemic illustrated, this supply chain is prone to disruptions that can quickly radiate out into dependent industries and cause parts shortages, delay projects, or hike repair costs. Not even hot tubs were spared from the COVID chip shortages. According to the White House, the chip shortage during COVID may have knocked a full percentage point off of America's gross domestic product and helped contribute to the sharp spike in inflation. The supply for chips powerful enough to run artificial intelligence applications also appears to be tight, creating new disruptions. The U.S. is attempting to improve the resilience of its semiconductor supply chain through, among other things, the 2022 CHIPS and Science Act, which is dangling over $50 billion worth of incentives to semiconductor makers to reshore that supply chain within the United States. But that effort may not be without risk. Pass the chips, spare the PFAS? Besides the general risks that might accompany a reshoring effort, semiconductor manufacturing involves hazardous substances and chemicals. So, efforts to boost U.S. semiconductor manufacturing could possibly see more hazardous substances crisscrossing the United States freight or roadways, or more hazardous discharges into the environment. According to the Environmental Protection Agency's enforcement and compliance history, there are 41 active semiconductor facilities in the United States with some form of compliance violation for waste discharge or related activities. One of the hazardous substances in the semiconductor materials stream is PFAS. The semiconductor industry phased out the use of PFOS in 2019 and has committed to phasing out PFOA by 2025. However, it continues to use many short chain PFAS. Indeed, PFAS are used extensively in the semiconductor industry, from the photolithographic processes that aid in fabrication to chemical processing, packaging, and in the assembly system lubricants, to name just a few places. The semiconductor industry considers PFAS as essential to many aspects of its manufacturing process and end products. Semiconductor makers have also been linked to possible PFAS discharges into the environment in both the United States and Taiwan. For its part, the EPA has proposed a new framework for evaluating the risk posed by new PFAS or by new uses of existing PFAS, a move opposed by some semiconductor manufacturers. PFAS isn't the only environmental concern hovering around the semiconductor industry. The menu of minerals leveraged by semiconductor manufacturers has grown from around 11 to over 60 today. Two of those newer minerals, gallium and germanium, were flagged by an EPA report as having, quote, minimal guidance for local permitting and control authorities to evaluate the potential impacts that these minerals could have when discharged into water. Quote, there are no federal pretreatment standards, national recommended water quality criteria, or state water quality standards to follow for establishing gallium or germanium limits, the EPA noted. There also appears to be limited research into the potential toxicity of these two minerals. According to the EPA, human health concerns from long-term gallium exposure in drinking water or soils are largely unknown. However, gallium health effects and ecological effects are likely similar to those observed from aluminum. The agency also indicated that information on the health and ecological effects of germanium are, quote, limited. The other thing that appears to be limited, at least for now, are gallium and germanium, at least domestically. While the U.S. does have deposits of the former, it's still 100% reliant on imports for its needs. The U.S. imported 50% of its germanium in 2020. For more information on this or any topic we're tracking, please visit us at www.core.verisk.com/EI. E as in emerging, I as in issues. While you're there, be sure to sign up for our weekly newsletter. And thank you very much for listening.